Okay. Well, it is our last lecture in geomatics. Last one. Now, no, I'm good. Okay, it's not our last time together because we have lab this week, but a couple of housekeeping items. First off, the at-home game. Did y'all get that? Yeah. Okay, all right. So you all can mess around with that. I mentioned this last time. I'm pretty sure I did, but I will say, in case I didn't, what that sheet is doing is, so like, let's say for a B, it is not calculating the grade that you need to get an 80. It's calculating the grade that you need to get a 79.5 because I round up, okay? So it's accounting for that part too, okay? Because I do round up. If you have a 79.6, you get a B, okay? So does that make sense? I can't remember if I said that on Monday, but the sheet is doing that. I know I said I was going to try and get your labs or your topo map graded before lab this week, and it just didn't happen. But what I'm going to do is, so I know the lab 12 will be very quick to grade because again, all I'm doing is checking the quality of your field notes. So it's either going to be like a 50 out of 50 or maybe like a 48 out of 50. So that won't be a big deal. My goal for the topo lab is I'm going to send everybody out a rubric, and my goal is by the end of the week. I definitely want to get all these assignments graded by the end of the week because next week I'm going to have finals to grade. So I kind of want this off the balance sheet. But our the other thing I'll mention, homework 9, hopefully that went well for most everybody. I know the area calculations might have been a little tricky, so we can talk about that during review. But I am posting the solution on Friday, okay? All right, let's talk about the exam, okay? We all know when the exam is, right? Last day, last time slot. What's that? Yeah, a.m. Yeah, yeah, that was a typo. 12:45 p.m. Sorry. Okay, let's talk about logistics. Okay, so one thing I mentioned, I'm pretty sure I mentioned it on Monday, but I want to be clear. I am not designing the exam to be 2 hours long. Okay, even though you are being given the full 2 hours, in my mind, this is just another exam. It just happens to be during finals week. It is not comprehensive, and it is not 2 hours long. So I am going to pare that down a bit. It is closed book, closed notes. You do have a calculator. You do have a formula sheet. A straight edge probably wouldn't hurt. One thing, I am going to give you the FE reference manual, the handout that I gave you. You're going to have that. And I am going to give you all the section template formulas. Okay? I'm going to give you those as well. Okay? Sound good? Your formula sheet, I say here that I'm going to collect them after the exam. I might just sort of like skim them over so that you can have them when it's all said and done. I know sometimes students want to keep their formula sheets for reference for later in their other courses or their careers. So I can respect that. I just want to take a look at it. But my rule does apply that I do want the formula sheet to be prepared by you. I want you to put effort into it. I don't care if it's handwritten. I don't care if it's word processed. I don't care if you take an image here and there out of the slides. But what I do not want to see is screenshot a bunch of slides and hit print. Okay, I want you to actually do make the formula sheet. Okay. All right, let's talk about the topics on the exam. Okay, so I've broken this up into 3 main areas: horizontal curves, vertical curves, and earthwork. But I do have some general items, and so like for example, one of the general items is you need to be able to express distances in stations and interpret stationing on route-based projects, because stationing kind of affects like all three areas. You do also just be able to generally describe surveying applications, some stuff on topo, construction, property surveys. I am not going to get into the weeds on that on the exam in no way, shape, or form. The star of the show really are the 3 main topics: curves, or horizontal, vertical, and earthwork. Those are the key facets of the exam. For horizontal curves, you need to be able to identify key features of a simple curve. So we're talking about what's the PC station, what's the PI station, what's the PT station, what's R, what's L, what's LC, all that. I think that's pretty easy. Given fundamental data about the curve, so given some properties, Be able to compute the D, the T, the L, the LC, EM, all that stuff. Make sure that you can compute key values of the curve based on, starting info. Yes?
On the test, are we going to be given like the equations for those?
That's this, the FE reference. Remember the 3-page thing I gave you? I am giving you that. But that doesn't mean you can't put that stuff on your formula sheet too. So, but yes, I will give you the FE reference manual, the 3 pages from the reference manual. I will give you that. You also need to be able to compute deflection angles and chords for a stakeout. So if I give you the data, what we did in lab, how distance angle to stake out the curve, you do need to be able to do that. For vertical curves, same idea. Make sure that you can identify the key features of a curve. So like, is it a crest curve? Is it a sag curve? What are the curve lengths, the grades, all that stuff. Make sure that you can compute the elevation of a curve using the general parabolic equation. So that, given the data for the curve, that's the whole point, is computing the elevations. So whenever we did that, we either did it at arbitrary or regular intervals, like either at some random point or at regular intervals for staking. And we also computed elevations at the minimum and maximum. And I say minimum or the maximum because it depends on whether or not it's a crest curve or a sag curve. And finally, be able to compute the required length to meet target elevation or the stopping or passing sight distance requirements. Earthwork, that's what we just finished. So make sure that you can compute the area of a cross-section of a station using either simple shapes, coordinates, or section templates. When it comes to the calculation, like the shoelace formula, I will probably give you like a table so that you don't have to reproduce the table on the exam. Like I'll give you space to do that. Kind of like with the Traverse exam, if you remember that. Like with the Traverse exam, I gave you like a template because I didn't want you to waste time drawing a table. Like, that's not a big deal. I've done that also on other exams in here, like the leveling calculations. For the other thing, so make sure that you can also describe, this second bullet's more about like terminology. So like what is shrinkage versus swelling? What are cuts and fills? Just the terminology associated with earthwork. Make sure that you can compute volumes using either average end areas or the pyramid formula, depending upon what region you're looking at. Don't forget that you probably need to account for unit conversions as well. For example, we calculate end areas in square feet, but then the volumes are in cubic yards, so you need to be able to convert appropriately. And finally, make sure you can do mass Hall diagrams, so cumulative volumes, and either plot or interpret a mass Hall diagram. Okay, and the rest of this is just the greatest hits on what's going on the exam. So these sets of slides are on Blackboard right now. So what I tried to do for the past few lectures is snip out like the most important stuff from those slides. So for example, here's the components of a curve, and then here's some snapshots from the reference manual that has like pretty much all the equations that you would need. For stakeout, there's the step-by-step process to stake out a curve. We've got the equation of a parabola for a vertical curve. So we've got the equation, we've got the min-max here. I also put sight distances according to AASHTO, and either stopping sight distances or passing sight distances. And I also put the crest curve and sag curve equation. So this is the crest curve equation. This is the sag curve equation, or sets of equations, I should say. For areas, we've got areas by simple shapes, either by triangles or trapezoids, and we've got the equation of the area of a trapezoid right here. We've got areas by coordinates using the shoelace formula. But again, I think this is actually a little bit more useful than just the raw math, because I think the pattern is easier to recognize than all this hullabaloo right here with all the index notations and whatnot. Finally, we have our section template areas, which I am going to give you these on the exam. I'm going to print these out for you, so you're going to have that. And then computing region volumes, we have either the average end area or the pyramid formula, dependent upon what region we're looking at. And that is everything on the exam, or at least everything that you need to review. Okay, I'm going to stop talking, and it is now up to you. Now let me do this. I'm going to pull up the notebook in case we need to do some calcs together if there's anything you want to look at. But the floor is yours. Oh, hold on. Let's take my caps lock off. Okay, floor is yours.
We're taking it to the same room?
Yes, in here. That's why, I mean, one of the reasons the university develops that schedule, like the way that they do it, is so that the room will be free. Because if you're going to give everybody 2 hours, you got to be very clear on when this room's going to be free. You know, because this room is booked right now 1 to 2 or 1 to 1:50. So if it's going to be 12:45 to 2:45, you know, well, then somebody else can't be using it.
With the section tip marks, are we gonna have to like identify which is which?
What do you mean?
Like,
Well, I'll put like a picture, say this is the level, this is the 3 level, this is the 5 level. I'll do that. And I won't, I'll do you one further. I will not say, here's a section, like pick one to use. I'll probably tell you, because at that point, it doesn't, I don't want to grade 12 problems that are all right. You know, let's keep it simple. So I'll tell you, use the 3 level, use the 5 level, use, you know, whatever. So. Yes?
Will we be using all 3 of those methods to determine area on the exam?
Possibly, but I'll qualify that by saying that due to the fact that I am still designing the exam to be, you know, be able to be completed within an hour, if I were to give you a problem where I say compute all 3, it can't be some ridiculously large problem. It's got to be manageable. You know what I mean? One of the things that you ought to keep in mind, if I give you a problem and I say compute using all 3 methods, you should be getting, for the most part, the same answer using all 3 methods. So that should give you some comfort that you're doing it correctly. You know what I mean? So. I like exams that have a way of self-checking. It's kind of like structural analysis. It all kind of checks itself at the end. So. Are you kidding me? What are you doing? Okay, I'm assuming it's still working.
What's the thing with the race going to be? You still doing monsters? Or?
No, I don't know. I don't know yet. We'll decide that day. It'll be fun. We'll find a good one.
How will we know who wins?
What do you mean?
It's only designed for 50 minutes. And we have the whole
I tell you what. That's a very good question. I usually send an email. So, okay, let's talk about logistics on the final. I do post. Now, hold on. I do post final grades to Blackboard, so you can see what you got on the final. I keep the finals, so I keep the finals. If you want to see how you did, you can always stop by my office, but I do usually keep the finals. But I'll send an email out to the class letting them know the grades are posted, and I will say who wins.
Can we build a parlay on it? Or
Can we what?
a parlay? Can we make at least a leg on it or something?
What?
I'm trying to gamble or lay my rent. Yeah. It's not a gamble. I know I'm going to win. But.
This isn't an economics class. This is.
Wait, so you teach gambling in economics class?
I teach risk.
Okay, close enough, close enough.
99% of gamblers quit before they win big.
I have no response, Mr. Coupler. No response to that. Does any? All right, let's handle each topic one at a time because I want to make sure you're getting value out of the exam review. Let's start with horizontal curves. Are there any specific questions or ideas about horizontal curves that were challenging or confusing. We generally had two main issues with the curves. One was given some basic data, compute all the properties, which to me seems very plug and chug. I will mention that it might sound silly, but just make sure that your calculator is in the appropriate mode. If I give you data and you're calculating it and the answers are coming out negative or not making any sense, it could be because your calculator's in radian mode as opposed to degree mode. The stakeout procedure is largely using a lot of the same formulas, just substituting some of the terms. So the only thing I can think of, I'm trying to think of things in terms of like tripping you up. I can't really think of anything in terms of difficulties other than I've mentioned it before. If you have the time, which you should during the final, I think it's usually good practice to do the math in your calculator and then do it again, because you should get the same answer. You know what I mean? Or at least, like, if you're using like a Casio or something, like review the screen, make sure the inputs look right, because you don't want to miss a problem because of a calculator thing. And that it happens, but I mentioned that. Yes.
On our cover sheets, are we gonna have to put the acceptable site distances chart?
Oh, that's a good question. No.
Okay.
That's a good question. I'll say no. I'll either provide the data or provide what you need in the problem. That's a good point. Let's not waste time on the formula sheet for that, or on your formula sheet for that. Yes.
What are the problems on the site distances going to look like?
So that's a good question. So there'll be one of these, like the ones where, like either this or this, where I give you a series of data about a curve, like grades. So like, how long does the curve need to be to achieve a certain site distance? If that makes any sense. So it'll be something like that. And remember, whenever you're designing either crest or sag curves, okay, so the idea is you don't know which equation's going to govern in design mode because you don't have the curve. So you use both of them. Now these, for example, for crest curves, these two formulas are derived based on the geometry of the problem, but the geometry of the problem changes dependent upon if your site distance is less than your length or greater than your length. So do both. And when you do both, what's going to happen is only one of them is going to yield an answer that makes sense. And that's the one that's the actual design length. So does that make sense? But yeah, it'll be one of these. It'll be a vertical curve. So like you may get also a conceptual question about like what is passing this, or stopping or what have you, but it'll be a vertical curve problem. Speaking of vertical curves, are there any questions there? I will say one question that was asked earlier before class started. This is not an Excel-based exam. There's no Excel. So, again, like, I don't know how to put this, but I don't expect calculations of that complexity on the exam.
Didn't we have, there was one on the curves homework that had the Excel, right?
Yes. And what I'll say, here's what I'll say. If I have you do a problem like that, I'm going to have to give you some data to make it a little more doable. Like I don't want this to be an algebra test. Although algebra is fun, but you're engineers, just saying. What's that? Well, now that's true. You got a little ways to go. Speaking, any other questions about vertical curves? I would say for vertical curves, be careful about your G values. Little g's are decimals, big G's are percentages. So like if you have a 2% grade, big G is 2, little g is 0.02. Make sure you're clear on that. All right. Okay, what about earthwork? About areas? Any questions about either of the three methods? I honestly think shoelace is the easiest, if you ask me. I do think shoelace method is the easiest method. Even though it can be the most computationally intensive because it requires you to do this a lot of button crunching on the calculator. But I think that the shoelace method is the easier of the three. That's just me. I think, honestly, ironically, I think simple shapes is the hardest because you are having to compute a lot of distances and, you know, a lot of line equations, and it's not hard. Like, it's easy to understand, but it just requires a lot of work. So
You say we're gonna have to use all three?
what I said was, if I make you do all three, I'm not going to make you do all three on a problem that is of gargantuan scale. It's got to be manageable so that you can do it in the time frame. And the other thing I said is, that's not necessarily something to be afraid of on the exam, because if you do it three ways, you should get three answers that are all the same. So if you do it and you get the same answer for all of them, that's a good chance it's right, you know? So it'll give you a way of checking your work. So it's just something to think of. What about the last stuff we did? Volumes, mass hall diagrams, stuff like that. Was that okay? Again, unit conversions, don't forget. This is an easy thing to forget, that there's square feet, but cubic yards. And what do we divide by to get into cubic yards?
27.
Okay, good. That's 3 feet in a yard, or 27 cubic feet in a cubic yard, yes.
Are there going to be like a question about interpreting mass hall diagrams?
Possibly. And what I mean by interpreting, it might just mean like, so what I'm getting at is, like, if I give you some cumulative volumes, like what should the mass hall diagram look like general sketch. What I'm getting at, I'm not going to make you do Excel quality plotting, if that makes any sense. It'll be manageable. But positive mass hall diagrams means you're pushing Earth along the stations. Negative means you're pulling it back. Negative mass hall diagrams means you've got to start here and pull the Earth back. So whenever you have a mass hall diagram that sort of like looks like this, good gravy, that is. I'm not that good, so. Okay. All right, let's try this one. Okay, so whenever you have a mass hall diagram that looks like that, for example, okay, so basically what you're doing is you're having to push Earth along the project until you get to right here, right? Because this is the point where the cut and fill's balanced. Anything from here on, so if it went like that, from here on you have to pull Earth back to that point. That's what that means. So it's just telling the contractor you're going to be moving Earth from the very beginning up to right here. One thing also on volume calculations, be careful that you're not just blanketly using end areas. That if you have a station that has from an end area to 0, you're using the pyramid formula, not the average end area method. Okay, so just make sure you're careful on that. All right. This is your time. I want to make sure you've got all your questions answered. How's everybody feeling about the exam? You feel nervous? Feel comfortable?
I feel like if I get a 33.7%, I'll walk out of here.
Maybe there was a problem in sending that at-home game out because maybe that was a problem. Because now it's like, oh.
Well, I think no, because like, if you go in knowing what you need to get, then you'll probably get it. No matter what it is, you need an 80, you'll probably get that 80. You need a 33.7. Pray to God you get that 33.7.
I don't think the exam is difficult. The one thing I'll say about this exam is I think this exam is probably the most, like, eclectic. And what I mean by that is, like, the Traverse exam, the whole exam was basically about the Traverse. The Traverse was a very involved calculation. That was all it was about. Whereas this, you got a horizontal curve form, you got a vertical curve, you got earthworks. There's a lot of little things all adding up, you know. So that might, I don't know if that presents a challenge or maybe it makes it easy. I don't know. But there's a lot of, like, individual topics on the exam. So that might be the only thing, in my opinion, that makes it challenging. So
I think you're the first professor I've ever heard to make a final within like the same amount of time as a normal class. Now I say that as a thank you, not as a complaint. Okay, before we jump the gun. So,
you're giving me ideas for additional questions on the exam.
okay, look. We talk about this. I'll say that like not bad if you don't do that.
I've made a believer out of you, Mr. Coupler.
I don't know about that.
Oh, it's not bad.
Just getting branded would be better than doing that.
What is that?
Getting branded would be better than doing that again. Still carry it with me everywhere I go either way.
Oh. Any questions? Anything that's concerning you, making you worry? What? What? Oh, now I'm gonna pry. Now I'm gonna pry it out. What? I got 22 minutes. I'm waiting. Okay. You're what? Okay, I give up. I give up. All right. Listen. I know that many of you have Thursday lab. Like, for those of you that have Wednesday lab, I guess we'll just take a break. Unless everybody's here for Wednesday lab, we can start early.
Let's do it right now.
All right, but hold on. Before we go, anybody have any questions? Last chance. Going once. Going twice. Okay. One final thing before I let you go, because I'll pull the code up one more time. It's been a blast having everybody in class. It's been a lot of fun. I don't usually teach lab classes, and it's been, like I know I've said this before, but it's been about 10 years since I've taught this class, so it's been a lot of fun. I do appreciate everybody's work efforts. You've all done a lot of good work in here. One final point of logistics. If you have not yet done your course eval, please do it. Again, on the off chance, there's a possibility I teach this class again. As you know, we are in the process of hiring a transportation professor, and dependent upon who we hire, they might teach this class or I might teach this class. So I do appreciate any comments or suggestions that you have for future offerings, because I do take it to heart. One of the stories I've told students before is that my very first semester when I was here, I was teaching steel design, and my PowerPoint slides had this dark blue background. They were white text with blue background. And so when I printed them out and gave them as handouts, the slides came out gray. And so one of the comments I kept getting on my course evals was, we can't read what we're writing on the slides because the slides are gray and our pencils are gray. you've got to change the color on your slides. I went, that's a good point. So now my slides look like this. So I do honestly take your feedback very seriously. Now, I mean, if you said Dr. Mike is a poopy head, like it'll hurt my feelings.
How'd you know?
So, well, I've heard it from my 5-year-old too, so it's okay. No, no, I mean, like, in all seriousness, if there's any suggestions that you have for improvement, I really do appreciate it. But like I said, it's been a blast. For those of you in the Wednesday lab, I'll see you here in a little bit. For those of you in the Thursday lab, I'll see you tomorrow, and I will see you all next week for the celebration. That's all I got, everybody.
So